Today we're going to look at another example object. You can see it up here in the top right corner. It's got a few tricky parts to it, some things that are a little difficult to figure out initially, and also one mistake in the drawing, and it's going to be up in the bottom corner. I'll talk about it when we get to it, and the diagonals that are cut into that. They have a mistake in one of their measurements. So let's get going. We're going to start with a new part. We want to make sure our part is in millimeters, grams, and seconds. We can go up, and in the question on the PDF that I hand out, you'll see that the material that we want this to be is AISI 1020 steel. So we can just start off by changing that. We'll go to edit materials. We'll pick our 1020. There's no call out for whether or not it's cold rolled, so we'll just go with the standard. Say apply and close. All right. We're gonna go, and if we look at this, we can see that it is kind of bound around a center point. We don't necessarily need to use that. We can extrude off one side, but we are going to draw this front face with the C to it first. So if we go to our right plane and we choose a new sketch, we can start off by drawing that. And I want to, if you look at the measurements, you see a lot of the measurements are from the bottom left-hand corner up. So let's just start with our drawing based off of that bottom left-hand corner. And you can see that we have, in the directions, you can see that we have two global variables, A and B. In this case, we can see in here that there's no multi-part to this, but let's just pretend like this was part of the test, and maybe there would be a multi-part. So let's put those in as global variables as well. So we'll go to our tools, go down to equations, and we'll make global variable A is equal to 50. Global variable B is equal to 70. Say OK. And we're out of that screen. All right, and we've got those two done. And if we look at our drawing here, we can start off with a pretty simple box. And it took our drawing away. So there we go. We've got sketch. We're going to go here. We're going to go to our rectangle tool. And we will draw our rectangle. Push escape. Smart dimensions. This bottom dimension is equal to A. Remember, you want to put the equal sign and then global variable and choose A. Enter and enter. It will have the summation sign next to that to show you that that's one of your global variables. And then we can do the same thing here. Equals global variable and B. Enter and enter. All right, so those two are entered in. We're good to go on that. And now we're going to do some of our other features here. We can go here, and let's start with the circle. We'll draw a circle here. Escape, smart dimensions, and we see that we have a diameter of 38 and a height for a center point off the bottom is 27. And you can see that our next dimension is actually off this back wall. So just in case some of these global variables will change, we want to make sure that our dimensions are drawn correctly. So we'll go off this back wall here, and our value here is 27 as well. All right. So another thing that we have here is we have to make an assumption. I don't like that in this drawing there's an assumption here, but the slot that's cut out, if we look at the other drawings, it looks like it is, so in the PDF that I sent out to you, look at the other drawings, it looks like this slot is centered around the center point of the circle. So we're just going to make that assumption and go with that. So we're going to draw on our two lines. Easiest way to do this is to make sure you're drawing a horizontal line across, and just go to that circle, push escape, and we'll go in here and we'll do the same thing here, push escape. Let's define where these lines are at. So we go to our smart dimensions here, and this one we're actually going to have to break some of our, so it says it's already defined, which means we probably accidentally drew it off of the center point on this line. So let's select this line here, and we want to choose this midpoint, and we want to delete that that part of that. So now this line is no longer defined, which is fine. So now we'll go into our smart dimensions, and we can look at our drawing here, and we see that it is a gap of 19 millimeters. So if we divide 19 by 2, that's 18.5. So we know our height off of the center point is 18.5. We'll click here and click here, go across, not 18.5, 8.5, or excuse me, 9.5. There we go. And that now says that line is defined, and then we can go here and we can go down to this line, pull across here, and we can say this is 19. Now that line is defined. Say OK to our smart dimensions. And now we want to go in and we're going to delete some features here. So we can go and we can click on this circle and click on, push control and click on this line. And we can say convert entities. So that will convert our entities there. Now we can go trim entities, and we should be able to go in, trim out that line there, and trim out our center there. Okay, and that gives us the C cut into that hole. Once again, everything is still fully defined. Everything's in black. We can now move to this slot cut that's up on the top here. And an easy way to do that, we'll just do our line tool. Start here, draw across, make sure it's showing it as horizontal, down, back over, push escape, and now we can go into our smart dimensions, and we can say that we want this slot to be cut out at a 3.3, say enter. We want the distance from here to here to be 12.5, and we want our line in to be 29, so 29, and there we go. Now everything is fully defined. We can push escape. We can now select this line, convert entities, say OK, trim entities, and trim out that center line. All right, so now our shape is fully defined here, and what we'll want to do is we'll want to extrude this piece back. Say OK to the trim, go to features, extruded boss base. At this point in time, we can extrude it all in one direction, or if you wanted to have something where there's some features here like the slot cut that we could mirror, and maybe having it mirrored around a plane would be helpful. Let's mirror it right now just in case you guys want to go in that direction when you do this. I don't feel that it's really going to save much time in those features, but we'll just do it that way anyway. And we can see that we have 67 is our total width. So if we divide that by 2, that's 33.5. We can go 33.5 and 33.5. Say OK. All right. Next thing we want to do is let's do the X on the back. We can select this face here, go normal to it, and choose new sketch. This part was a little bit tricky, mainly because we have, like I said, up in the corner here, we have this 9.6 and the 4.8. And the way that that is drawn, it makes it look like our distance to, from the tip of the corner to the tip of the edge is supposed to be 4.8. And that's not necessarily the way this is drawn. It's more that from this center line to the one edge would be 4.8 if we were going perpendicular, and our gap between the two edges is 9.6. And it just doesn't look super intuitive the way the drawing is showing those lines. The way I did this is I chose to draw some construction lines here, and I went point to point, push escape, and then point to point, push escape. Once again, there's many ways that you could do this. I just found that this was the quickest way to do this. And then if you click on this line here and say offset entities, and we look that we our distance between these two lines is 9.6. So we're going to offset from the center line 4.8. So we'd say 4.8, say OK. And if you didn't have two lines right away, you might need to click this bidirectional. And then you say, all right. And then we can click on this line and do the same thing and say offset entities and make it bidirectional 4.8 and say OK. So that draws our lines here. And we have some stuff we need to clean up. And to do that, we want to select, we'll say convert entities, and we'll want to select this line, this line, this line, and this line, and say OK. All right, so that grays it out and says, hey, we have an object here we can work with. But we want to trim our entities before we do that. Now, if you accidentally trim out these center lines here, it's going to say that your object's not defined anymore. So leave the center lines in while you're trimming your entities. And we'll just go around. You can trim out these edges too. And then this is where you could accidentally trim out your center line. So you just want to be careful that you don't do that. And go in, and there we go. And now we see that this is fully defined. Say OK. Go to features, and we're going to do an extruded cut. If we spin around here, we can see our extruded cut. We want it to be 1.5 deep. 1.5. All right. Checkbox, and there we go. So that is now cut in. Our next part we have is a hole that goes through the top. We can go up here. We can say to this surface, we want to do a new sketch. Do circle. Draw in our circle. Say OK. Go to our smart dimensions. We can see that this circle has a diameter of 6.3. 6.3. And it is 33.5 from the edge, so it's centered on this plane, and this is where you could have used that center plane also on the next part. So we say from the point here to this line is going to be 33.5, and from the front surface to this line is going to be 8.3, or from the center of the circle to this front line is going to be 8.3. All right, now that circle's fully defined. Say OK. Go to features. We want to do an extruded cut. And I want to do, instead of a blind cut where we measure this out, I want to do up to the next surface because it says that in the drawing, through to slot. So you could say through through all. Well, we don't want to do through all, so we want to say up to surface. And then we can spin around here, choose this as our surface, and say OK. Now you see we have a hole that goes down through to that slot. Our next part is the trickiest part, and that is these little slot cuts in here. And so the way I did this is I went and I said reference geometry. I'm going to have to do two reference geometries here. So I'm going to do an axis, and you can see it has an option here for how you make that axis. And one of those options is around a cylindrical conical face. So if we just choose this face here, it puts an axis in here. So now we have a rotational axis for those. We say okay. And then I want to create a plane here. And so I want this plane to be in aligned with this axis so that we can make our slots in here, because we can't draw off of this plane here, because if we were drawing off of this plane, the cutouts wouldn't be correct for how we want this to look. So if we go here and we go up to reference geometry and we choose plane and we select this surface here, actually we want to say, I want to delete this. I had that axis selected when I chose that, and we want to go back here, and now we just choose this plane here. All right, and we want to be up from that surface, and we can see that our distance between these two surfaces is 19, so 9.5 millimeters is going to give me the right height to be halfway in between these two surfaces. We say okay. All right, that's the plane that I now want to draw on. So we'll go to this plane here, and we'll choose new drawing or new sketch. And then I want to rotate down, and I want to make sure that I'm drawing, we look at those slots, and those slots are going to be they're going to have a radius of 20. So I want to make sure that I'm drawing 20 millimeters away from this center axis. So what I'm going to do is I'm going to choose to draw in a reference line here along this plane, and I want to draw it in so that it is horizontal along the plane. We say okay, and then we can go here and we can say to smart dimensions, and we can say from this center axis to this reference line we want this to be 20. All right, so that gives us a reference line there. Say okay, and then I'm going to just draw in two rectangles. And I want to make sure that I'm drawing them in from that line that I made. All right, and now we can go in and we say smart dimensions. Now what you could have done, like I said, if you had we drew this around this plane, you could do all of this in one step and then mirror your extruded cut that you're going to make, or your evolved cut around this plane or on this plane, and then it would just do the other one over here. Well, I don't think that it saves you enough time to do the extra steps. So we can go in here and let's do our drawing. So we know that we want these slots to be 1.5 wide. 1.5, and we want them to be 1 point high. Alright, I accidentally clicked the point there. We zoom in here a little bit easier. We'll say 1. Alright, and then from this edge to this part of the slot is going to be 12.5. And Solidworks is smart enough to know that you want to still be on this plane, so it will bring that edge up to this plane. So we can click here and over to this edge, and we can say we want this to be 12.5. All right, now, so this rectangle is now fully defined. If we zoom out, our next one, we want to go in here and put those same dimensions in. So this is 1.5. This is 1. And then we have our value here from this edge over to this edge in our drawing is 42. So we can come here and click on this face, and click on this face, click on that, and say 42, and that should make them both fully defined. All right, now we say okay. Now the next thing we want to do is we want to do a revolved cut. And what we'll do is we can tip this a little bit so you can see how this will work. Revolve cut here, you can see that it tries to do that around the line that we had because it picks what you're going to revolve your cut around. We want to go in, select that line, and change it so that it's revolving around this axis. And now you can see that it's doing a revolve cut around that axis. And we made this part so that it was, our diameter for this cut would be at 20, or our radius for our cut would be at 20. So we say okay, and you can see that it cut that slot in on both those places all the way around the circle. So now we can zoom out. Alright, so here's our finished piece. We can see that, you know, we've got the two slots cut in there, we've got the X on the back and the hole through the center. Let's go into the orientation that the drawing is showing so that you can see it finished. You can do that by going up here, and we will drop down here and choose this isometric view. Alright, and that's in the orientation that the drawing is showing. You can see that everything looks right there. We can go here, and our reference plane and our axes, we can hide those if you want, and that just cleans it up a little bit so that you can see the drawing there. The other views, you can look up in the other views here and go to our display style, and some of these, so like if we click this one, you can see now the slots cut through. You're not going to use this too terribly much, but this lets you see the entirety of the cut. All right, so finally what we want to look at is what the question was, and the question was asking what the mass is. And we had a multiple choice here, and so we can go up and we can go to evaluate, and we can go to mass properties, and we have our drop down here. We already selected what our material is, and we can see that our mass here is 1,127.72 grams. And if we were to look at our multiple choice in the PDF that I sent out, we can see that the selection of D is 1,127.72 grams. And so therefore we did this correctly, and we made this assumption here on the corner was correct, and then also the assumption here about how this cut was made is correct. Like I said, I hate to do assumptions when we're doing these, but in those cases there was enough vagueness in the drawing that we had to make those two quick assumptions. So if you have any questions about how this one was done, feel free to reach out to me, and we can talk about it later. Thanks. Bye.